Review in preparation for the finals. This class reviews the material given to you for this course in order to prepare you for the finals. That's the goal here. Programming fundamentals. This is for most of you the first course in programming. Consequently, okay, you are given codes and code fragments through this course for your practice. If you go back from the first course, you will see that each time any idea is explained, it's explained by a full program or a programming fragment. And this programming fragment and the programs are for your practice. Programming is not about talk. It's not talk. You cannot talk and hear until you can program. That's not going to happen. If you are not yet programming by now, the reason is simple. Because you refused to do what I told you to do at the beginning, which is, at the time I give you a programming fragment, the best thing you should do is to type it in as I've given you. Make sure it runs, make sure you have done everything correctly, and then study and see whether you can modify it a little bit to play with it. If you have done that with everything I've given you, you are already a programmer by now. I can bet that. If there's anybody who has done everything that I've told him and is not yet a programmer, let him say so, because that is without exception. If you have been doing what you have been told to do, by now you're a programmer, because programming starts by mimicry, imitation, making your mistakes and learning from it. There's no way you can short circuit those processes. That is the reason why this course is like this. For anything we say to be relevant in the acquisition of a programming skill, there must be a practical component. It is that practical component that creates the environment for any meaningful discussion. It is when you are already programming that I can teach you to program. It is when you are already doing something that I can teach you to do it better, that I can teach you to do more things, and I can teach you in the context of programming and everything. Even before I come to you, I do not just give you stuff. I test them out. I check. I check by running them through, and you will see examples as we move on into this class. Because of this, you are required to copy all the codes. Please notice the emphasis all, not most, not some, not a few, but all the codes you are given, all the codes, and make them run on your own system. Because of this, you are required to copy all the codes you are given and make them run on your own system. All the codes in the slides, you are supposed to copy them and see that they are doing what the slides say they should do. They look trivial, but you are supposed to do that. If you are not yet programming, it is because of your disobedience to that simple instruction. It costs you something to be disobedient, and you may pay. If all you will pay is by failing the course, that's a small price. You may pay by being hungry after you graduate, because everybody that can program Python will be employed. There is nobody who you would even be working when you are on Newcom if you can program, because the way everything is going IT these days, you will be so much in demand. It doesn't matter what you study. You will just be using your programming with your engineering to combine together to give you your daily bread. And if you keep disobeying, that is where you are going to pay the price, not even the passing or failing the course of not getting a good grade. Those who program well, I have people who have gone out of the university who did not see it keyboard before they came to Unilag, and they are making cool incomes right now. So that is something you can do, and all they needed to do is to just obey simple instructions, copy all the codes, make them work, and then learn programming gradually until it becomes part of you. And then you can now understand. It is after that we can now teach. The talk comes after you have already started to program. You are also required to modify and practice these until they became your own code. A code can start being mine. You copied me, and you practiced it, After some time, ideas will germinate in your mind, and you add your own ideas to the code that even if I see that code again, I will not even remember, I will not even recognize mine. By the time you have gone through that, you have mastered that code. If all you are doing is reading the code and nodding your head like a wizard, if that's all you are doing, you are not going to be able to make it. And that is one thing I've been saying since the beginning, and I will continue to say it because it remains relevant. Your first assignment was therefore to go through all these code fragments and become proficient in the basics of programming. These code fragments help you to become proficient in the basics of programming. Scalar types and collections. The course used the elementary concepts in set theory as a fodder to introduce you to how programming is a model of the real world. When you are programming, you are trying to give a model of some things you might have done on your own, but you are trying to tell the computer to do them instead. So as much as possible, you must be able to define those things well. So when you are defining them, they are models of things you could have done without a computer, whether there were computers or not. What you are doing in programming is to change the set of instructions that are real to a set of instructions that the computer can understand and execute. So it is not away from reality. It is actually, in fact, a model of reality. So this course used elementary concepts in set theory as a fodder to introduce you to how programming is a model of the real world. We capitalized on the idea of sets as introduced to you in school, secondary school, to demonstrate some concepts in Python programming. In fact, we use school SAT examples, SSG examples, and even the ones that came in the exam, and say, okay, look, how would you tell the computer to answer this question for you in SSC? And those are things that show you how the programming models the real world. After all, nobody was expecting you to write a program in your SSC. Yet, we can turn the question to a question that the computer can provide answers to by giving those instructions in the language where the computer can understand, and you see that the computer carries out those instructions. Simple set operations were shown to be approximately modeled in Python collections with similar semantics. So semantics there mean meaning, similar interpretation. So when you talk of a set in your mathematics and you see a set collection in Python, you are basically dealing with the same things. These were not done primarily to teach you about sets, even though if you learn about sets in it, good, but that wasn't the reason. On the contrary, they were used capitalizing on the fact that you know about sets to teach you some basic types and controls in the Python language. We are using what you already know, what we think you already are familiar with, to now introduce new concepts into how to translate your instructions to a way the computer can understand by using instructions you already know how to interpret on your own. Because if the instruction is strange and the language is strange, you are trying to cope with two different incompatible things at the same time. And that may be hard. But if you know one thing, and we use that one thing you know to explain the other thing, we are hoping that that way, your ability to program will greatly improve. That is what we were thinking will happen. If it hasn't happened to you, it could be because you have not been fully obedient in typing all the examples. Not most, not many, but all the examples, all the code fragments. If there's any code fragment anywhere in previous lectures, please, 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 do not be neglectful. Don't be negligent. Go and bring it up all into your own computer and make sure you can run those code fragments and create the environment where those things eventually become your own, because you can also add your own ideas to them and make them such that I don't even recognize them again as something I gave to you. Those code fragments may be small, may be few, may look trivial, but there is nothing trivial in understanding the basic steps of printing things in the computer and getting a running code. Getting a running code out of the computer is not a trivial matter, no matter how short the code is. If you can do that, you can do a simple thing, you do 2 simple things, you do 3 simple things, you do 5 simple things. By the time you are doing 10 simple things in the same code, you are already writing a good program. That is how it is. But if you not start, if you think it's so trivial that you will not start, that is, you are giving yourself the sentence that you will never know how to program. So these were done not to teach you about sets. On the contrary, they were used capitalizing on the fact that you already know about sets to teach you some basic types and controls in the Python language. Critical step. For those that did not understand the strategy, it is not too late. For those that did not understand that strategy I've just explained, it is not too late. Do not attempt to understand the newest things we have done, like object-oriented programming and inheritance and polymorphism, which I will explain a little bit more, until you have gone through that original step and you know how to run those simple programs and make them yours. They may look trivial. They are not. They are needed to give you sufficient familiarity of the environment, of the way things work in Python language, and how to program in general. You will make mistakes. You will forget to type the semicolon. You will forget to type, you will forget to put the correct spacing, and you will be punished for those things. And it is suffering those punishments that force you to organize your mind in such a way that you can actually program. It is only after you have become familiar with these things that you can begin to absorb subsequent materials. Today, I'm going to go back to some of the earliest programs I gave you, and you will see that you are now only in a position to begin to understand them after you have gotten some theory. But if you did not practice those things early, it's not going to help you. Luckily, especially for those that enrolled late, those people that came by direct entry, by JUPEB, and some of these things, all that we did before you came, all is recorded. And you will do yourself a lot of good in the time left to review these and follow the rules. If you have just come in by JUPEB and you obey the rules, you will be doing better than people who have been here all along but did not obey the rules. Even in the amount of time that is left, there is enough time to catch up and to be good and to do these things. There is enough time. So do not be discouraged. Go through all the notes, which begins by explaining to you how to install your Python environment and getting them working. And now give you some basic baby steps in programming. Do not assume that those things are trivial. They are not trivial. The fact that something is easy for you to do doesn't make it trivial. So go through those things, and if you are making mistakes, don't let somebody type it for you. Type it yourself. Make your mistakes, learn from those mistakes, and you'll find out that as you do more and more of these things, you are going to make fewer and fewer mistakes, and after some time, the things become part of you. You are already on your way to prosperity, because there are not a lot of jobs around waiting for you today, but it is not possible for you to know how to program well in the world we are in today and have no job. You will have not just a job, but a very good job, and you will be internationally competitive, and you'll be internationally employable. So do not waste your life, do not waste your time, do not sentence yourself to the time of parading the streets of Lagos or any city in Nigeria. I beg you to apply when you can take your fortunes in your hands now and begin to master the program. And it also can help you in other courses, because there are so many things about programming that can actually accelerate your understanding and modernization of virtually everything you are doing in the university. This is where everything begins. For instance, next time, for those of you who will take the engineering graphics, we will build on the programming advantage we have got here. And if you fail to practice now, and you fail this course, You are going to be punished again next time if I am the person teaching you engineering graphics, because I'm going to use Python to teach it. So better start now. It is not too late. There is still enough time left to get things correct. Those of you who didn't do it right before can go ahead now and try to change your ways and do these things that you should have done all along. So that is the critical step. Go back to the first set of slides, which have like 170 slides there. There are no less than 20 or 30, programming fragments there. Practice every one of them. Practice every one of them. Don't practice many of them. Don't practice most of them. Practice all of them. All. A-double-L. I cannot overemphasize that. Don't just read and memorize them. Not going to profit you. Not going to profit you. Memorization. If memorizing things have worked for you all the time, you went to primary school, you crammed. You went to junior secondary, you crammed, and you got A's. And you went to senior secondary, you crammed again, and you got good grades. You went to JAM, you crammed, and you passed. You have reached the bus stop of that here. It is going to fail. Cramming as a strategy to pass will fail in this course. And you will see it. If you don't know it now, you will see it at the end of it. That the way this course will be examined, those who cram will fail it. But those who obey the simple ideas of practicing all the codes that they've done before and getting themselves ready, will find that the questions that we will ask will become natural and they will score A in this course. And it will be effortless. The night when the exam of this course is going to take place, you won't need to read anything because it is the skills you have acquired that will be tested, not what you memorized. How do you use things rather than what do you remember? So if memorizing things have worked for you, primary school, junior secondary, senior secondary, you have reached that bus stop. Think again. This is one thing that it will fail in. Reason is that programming is a skills acquisition process. Programming is a skills acquisition process. It requires a knowledge of some basic ideas. These ideas cannot be fully digested until you practice coding and execute working programs. Just like you cannot learn the piano or driving a car, etc., by simple memorization. Just memorizing. Oh, know where the steering wheel is, know where the gear shift is, know where the brakes are, and know where the clutch, and all those ones. And you cram all of that, and thinking by so doing you can drive a car. If you think that is stupid, that is exactly what you will be doing if you try to memorize in this course. Memorization is only useful for a bit, but it's not going to land you in the passing grade or knowing what is happening here. And this course is so critical. It's so critical to your other courses in the university, to your life, and to whether you will be poor or do well in future, that I advise you, go back and obey the simple instructions you were given at the beginning, which is practice and type in each and every code fragment that you have gone through. If you do that, by the time you are at the end of that, you are already programmed. And then you can ask better questions. And I will show you today where to find answers to your questions in a way that will be very convenient. And as you are doing it, but there are so many ways on the internet to get answers to your questions. But if you are not working, you cannot ask reasonable questions. Just like you cannot learn the piano or driving a car, etc., by simply memorizing, programming can only be learned by programming. There is no other way. Earlier classes. Our first two classes took you through obtaining your own Python licenses. Python is free and you don't need to pay anything. And most of the other things like the Visual Studio Code environment that we use are also free. The first two classes, if you go through the videos and slides of those two classes, you will understand how to get your Python licenses and creating your own, how to create your own working environment. Some things may have changed slightly, but the essence remains the same. And if you have difficulty, there will be somebody or the other in your class that can show you how to get that done. That's an essential step, getting your own working environment. Some things, go back to the beginning of and work your way up. It's not too late. It is not so hard. This same course has been taught to secondary school children, and they were able to program. I taught people in junior secondary this same way, and they could program. So you are a senior, you know more, and it should be easier for you to learn faster than them. One thing I will also say is that some people have asked me, why can't you use other Python environments? You can use Python and other Python environments, of course, and you won't lose anything. But if we are going to use the same thing in another course like graphics using Autodesk, AutoCAD, Fusion 360, the application programmer's interface in that language, as far as I'm aware, only recognizes Visual Studio Code. That is the main reason why I insist on Visual Studio Code in this course, because it is not good for you to learn to program this time, and then you have to go and learn new things next time just to be able to use the programming language you learned. I am not saying that Visual Studio Code is superior to so many other environments that you can get. There is one called Spider. There are several environments that you can use. But please use Visual Studio Code as much as possible, because it is good for the continuation course. The application programmer's environment, the API, the interfaces are only workable in Visual Studio Code if you are using the Windows environment. If not, you are on your own. The first error many make is that they can cope by bypassing the critical step of practicing. Unfortunately, they will pay a heavy price unless they change their ways. They will pay a heavy price in this course. They will also pay in other courses that I will teach. If you are taking any other course from me, this is not the only time you are going to pay for disobedience. You are going to pay more later on. But why should you pay? Why can't you just do the right thing and move on? It is not too late to do the correct thing. There is still enough time, but it may just be that you won't sleep. And after the exams, you can sleep as much as you like, but stay awake and get things done right at this point. Basic ideas. Every Python program is a composition with word-like tokens. The things that look like words, we call them tokens. These tokens are classified by the meaning that Python interpreter will assign to them. So whenever you use a token, Python is going to ask, is this thing an identifier? Is it a reserved word? Is it an object? What is it? So since Python is going to interpret, it is important that the same interpretation Python is likely to give you is the interpretation that's in your mind when you are using it. And that is actually, as you are doing that, you are learning to compose your program using word-like tokens. They may be identifiers, reserved words, punctuators, operators, etc. The way a token is used depends on the meaning Python gives them. The first step is to understand this and therefore use the tokens correctly. There are tokens when used in the wrong way will cause you stress because the computer will not know what you are saying and is not going to interpret your language correctly and is going to give you the wrong interpretation. Python is a language. Like human languages, you do not teach a child to speak by taking her to the library and reading all the books there. You don't just go and take the first book and read it to the child until you read all the books in the library. You won't even go beyond the first floor before the child is 70 years old. So, and the child wouldn't have learned how to speak. Instead, a child learns by the baby steps of mimicking others in daily intercourse with society. Instead, a child learns by baby steps of mimicking others in daily intercourse with society. As the child asks for water, asks for mama, asks for milk, cries and shouted at and replies, all those things that is exactly the way you learn. You learn in the same way. Practicing simple codes is an important step. Make your mistakes and learn from them and do better. That is it. You may even have the right code, but you type it wrongly and the computer complains until you are able to finally find out what mistakes you have made. The mistake may be trivial. You may knock yourself for making that mistake, but that is how you learn. That is how everybody learns. Anybody who can program went through that step. It's just like when you are driving, you see all the people driving on the road. You will never realize that they were once learners. They will be impatient with learners, hooting and doing all sorts of things on the road. But there was a time when they too did not know how to drive. And somebody is showing them and they were afraid. They didn't know where to press. That is how it is in learning anything new, especially if it's a language. Like human languages, you learn by the baby steps of mimicking others in daily intercourse with society. You learn in the same way. So I write you code, you mimic it, type the code in and see whether you can run it. And it says whether you understand it well enough to add to it, and whether you can add enough to it to make it do other things than what I intended. And once you have created that, you're on your way. That is how the programming language is taught. Now we get to, from the tokens, we go to statements. Tokens are arranged into statements. These are the closest approximations to sentences of human languages. A Python statement is the closest you can get to a sentence. And just like sentences, a sentence can be short. There are sentences that contain no more than 1 or 2 words. So also there are very simple Python statements. There are sentences that can be very long. There are also compound Python statements. So we will need to learn the structure of these different statements so as to be able to react appropriately. Statement types are several to many. The simplest statement can begin and end in a line, can be very short, can even be a single token. There are simple statements that are on several lines, can be on many, many lines. Sorry, can be on several, there are simple statements that can be on one line, and there are simple statements that are on several lines. But a compound statement has a more specific structure that the structure necessarily goes into several lines. So a compound statement can also contain controls that dictate the order of program execution. So compound statements are different from simple statements because they have a particular structure. They have a header and then they have a block body. Whereas a simple statement just can be on one line. And even when it spills to another line, it's still taken logically as a single line. But a compound statement is logically several lines, but it's still a single statement, no matter how many lines it contains. It can contain 2 lines, it can contain 4 lines, 50 lines, 1,000 lines. A single statement can contain 1,000 lines. But by the time you understand the structure, you will see how those things work. Ordinarily, a program executes statement by statement, just like you read a book sentence by sentence from the beginning until you get to the end. The difference between that and programming is that sometimes program looks more like a hypertext, because in a hypertext you can be hot linked to another part of the program, another part of the text, and moving back and forth, because the control system in a hypertext, the kind of text you have on your internet web pages, those are hypertext, because as you are reading, you can just hot link to another part and then come back again and so on. So it's like a material written, but not in a book, but on the computer. That's how it looks. That's what it looks more like. Simple principles. The ideas in programming are based on a set of principles. These principles are very simple, but they are logical. They are logical in the extreme. The logic is not forgiving. The logic will always, so programming languages are exceptionally logical. So the principles are simple, but they are logical. Python, like any other programming language, is rooted in its logical structure based on a few simple ideas. It cannot be overemphasized that you cannot learn these by memorization. The only way is to practice simple examples until the logic becomes imbibed through practice. The numerous simple examples at the beginning must all be executed, modified, and improved for you to gain the basic understanding of programming. And again, I repeat, it is not too late. If you are getting tired of my repeating this, please notice that that emphasis is because of how important it is and how much I know you will not do it unless somebody is there forcing you. And that is what you must do. And if you don't do it, you are going to pay. I want to emphasize it to you, bore you with repeating myself so as to avoid the consequences. Because by the time you get consequences, it would be already too late. And I don't want you to wait until that time.